Okay, quick, let's go through this classwork and see how you did. The first was the limit of sine of 3x over 4x, and if you put sine of 0, 0, so it's 0 over 0, and you can use L'Hopital's. So then take the derivative of sine 3x, and it's 3 cosine 3x, and 4 cosine 4x, and so now cosine of 0 is 1, so you can use direct substitution, and you get 3/4. Number 2 is the limit as x goes to pi of x minus pi over sine x. So pi minus pi is 0, and sine of pi is 0. So you get 0 over 0, and you can use L'Hopital's. So then take the derivative of x minus pi, and you get 1, and the derivative of sine x is cosine, so 1 over cosine x. Direct substitution, now cosine of pi is -1. So you have 1 over -1, and you get -1. Going on to number 3, you had the limit as x goes to 0 of x minus sine x over x cubed. And, okay, so it would be 0 minus sine of 0 is 0, so 0 over 0, so you can use L'Hopital. So take the derivative of this, and you get 1 minus cosine x on the top and 3x squared on the bottom. Still not there, because if you substitute in, it's 1 minus 1 now, because cosine of 0 is 1 over 0. So you still get 0 over 0, so you're on L'Hopital for the second time. Putting in 0, taking the derivative of 1 minus cosine x gives you 1 minus negative sine x, but that would change it to a plus. So 0 plus sine x over 6x, but that's still 0 over 0, so you use L'Hopital for the third time. Take the derivative of sine x, that's cosine x. The derivative of 6x is 6, so you get cosine x over 6. Direct substitution is 1, cosine of 0 is 1 over 6, so 1/6 for number 3. Number 4 is e to the 3x minus e to the 5x over x. E minus e is 0, so 0 over 0. Right, this would be e to the 0. No, this is wrong. This is 1 minus 1, right? Is 0. So 0 over 0, you can use L'Hopital. So then it would be 3e to the 3x minus 5e to the 5x over 1. That's what you wanted on the bottom. So that would be 3 times 1 minus 5 times 1, and you get -2 for number 4. Number 5. The limit as x goes to 0 of tan x minus x over sine x minus x. Tan x is 0. So you have 0 minus 0 on the top, and sine x is 0. Sine of 0 is 0, so 0 minus 0 on the bottom. L'Hopital once. All right. Derivative of tan is secant squared. So we got secant squared x minus 1. And on the bottom, derivative of sine x is cosine x minus 1. So secant is 1 over cosine. So that would be 1 minus 1, still 0, and 1 minus 1 on the bottom. So you will apply L'Hopital's a second time. And now the derivative of secant is, it's secant x quantity squared. So you get 2 secant x, and then the derivative inside is secant x tangent x. And the derivative of cosine is negative sine x. So that's what you get. And if you use... instead of direct substitution right now, I kind of simplified it because I took the tan and wrote it as sine over cosine, and those signs would cross out. So I had the limit as x goes to 0 of 2 secant squared x over negative cosine x, and secant squared is 1 over cosine squared, which is 1, so that'd be 2 over -1, and you get -2 for number 5. Number 6 switches to infinity. You have x to the 5th over e to the 5x, and that would be infinity over infinity, which is also L'Hopital. Look, I got Christmas going on. So look what's happening. I have to get way down, so I keep getting, so next derivative gives me 5x to the 4th over 5e to the 5x. That's still infinity. Do it again, still infinity over infinity. Do it again, infinity over infinity. Go down, do it again until I get to 120 over 3,125 e to the 5x. And now, of course, this will be getting bigger in the bottom. Anytime it's getting bigger in the bottom, it goes to 0. So that was number 6. Number 7 is really easy. Don't even use L'Hopital's. I'm not even gonna like try. That's infinity for infinity, and I have to keep going like 5 times using L'Hopital. We know this is an x to the 5th and an x to the 5th, so the coefficients are 1/7. So that's the limit. So use the shortcut, please, for that. Okay, the limit as x goes to 0 from the right of the natural log of sine x over the natural log of tan x. They had to use this because you know ln doesn't exist where 0 is negative. So take this L'Hopital would be 1 over sine x over 1 over tan x, and that simplifies to tan x over sine x. And so I just rewrote that tan x as sine x over cosine x over sine x, and those two sine x cross out. So you're left with the limit as x goes to 0 from the right of 1 over cosine x, which is 1 over 1, which is 1. Number 8. Oh, did I skip number 8? Wait, 6, 7. Oh, that was number 8. Number 9. Okay. You have cotangent and tangent. Cotangent 2x and cotangent x, and so it's undefined over undefined. Now I would do it without L'Hopital's because I didn't even finish, because it gets like second and third derivatives in here. How do you remember? You remember how to do this? First, get rid of the cotangent. Cotangent is cosine 2x over sine 2x. So I changed that first one to that. That's this. And then cotangent down here would be the cosine of x over the sine of x. So that I got there. And to remember that cosines are what we want, because if you put 0 in, you're going to get 1s. But the sines are what we want to get rid of. And so if we, let me write it over here. If we rewrite it, the limit as x goes to 0 from the left of sine x over sine 2x. Do you remember you can multiply by 2 over 2 to get the sine 2x over 2x? So that would be 1. So I multiplied by 2 over 2. So this whole thing would now go away. This would be the limit of 1, this 2 included. And so then I have the limit as x goes to 0 of cosine, just do direct substitution, cosine of 2 times 0 is cosine 0, which is 1, over cosine of 0, which is 1, and then you have the times 2. You still have this 2 down here, so you get 1/2. Now, if you didn't do it that way, and you said, I'm going to use L'Hopital's, the derivative of cotangent 2x is negative 2 cosecant squared 2x over negative cosecant squared x. And that just gives you a more complicated problem. So you apply L'Hopital's again. Here's me applying L'Hopital again. I'm using product rule, get 0 over 0. So like I went here and I was like, oh my God, maybe I could simplify it first. But you can't. Look what you get. The minute you try to rewrite it like with sines and cosines, you got product rule again. So man, I would not do that using L'Hopital's. I would do it the way I showed you, using those tricks with the theorems that the limit of cosine x over x is 1. And number 10, the last one was the limit as x goes to 0 from the right of x over ln x plus 1, which is 0 over, the ln of 1 is 0, right? So direct substitution gives us 0 over 0, or L'Hopital. So the limit as x goes to 0 from the right, we're going to take the derivative of x, that's 1, and the derivative of ln 1, x plus 1 is 1 over x plus 1, so you get x plus 1 if you flip it. And then, so really it's the limit as x goes to 0 plus of x plus 1. Direct substitution gives you 1. 0 plus 1 is 1. All right, so that was the classwork.